It started with a rumor of a robot seen behind the wheel of a Tesla. At first, people thought it was fake, but then the footage dropped. A humanoid calmly steering, changing lanes, and parking with zero human help. This wasn't a car commercial, it was a turning point. The Tesla bot, once just a walking prototype, was now driving like a trained human. Not in a simulation in the real world. And if a robot can drive today, what else will it be doing tomorrow? The road so far from stage promise to general purpose. The arc is surprisingly short. In 2021, Tesla put a stake in the ground. A general-purpose humanoid that will handle dangerous, repetitive, and boring jobs, with the audacious claim that it could one day be more significant than the vehicle business. Skeptics snort first at the stage suit, then at the shambling prototype, until the updates turn steadily more surgical. By 2022, the bot is walking under its own power, grasping objects, and, crucially, sharing DNA with Tesla's autonomy stack. The pitch isn't robot as sculpture. It's robot as a new body for a brain we already know how to train. Where other robotics shops handcraft flowing motion and then bolt on perception, Tesla starts with perception and policy learned from billions of fleet miles and teaches a body to obey it. Late 2023, Gen 2 arrives lighter, more stable, with softer hands, better back drivability, and a noticeable jump in finesse. Engineers make a point of filming manipulations in real time without cuts. You can see eggs cradled and stacked without spiderweb cracks, wires plugged without the jittery servo shake that haunts older robots. By late 2024 and into 2025, you hear a phrase again and again from Tesla engineers and watchers. One brain, many bodies. Cars, trucks, factory cells, then a biped with eyes, fingers, and an update channel. The public headline is always the big leap. Gen 3, V3 in Q1. But the quiet headline is more important. Every month, the same learning system gets better at seeing, predicting, and acting, no matter what body it's inside. That's why the notion of a humanoid that drives doesn't feel like a stunt from Tesla's point of view. They already have a network that observes lanes, agents, intent, and affordances, and outputs a policy that manipulates steering angle, throttle, and brake. In a car, those go to servos. In a humanoid, the same intent becomes wrist torque, thumb pressure, and ankle actuation. The outputs change. The brain doesn't. Is there an official, flawlessly documented, public demo of Optimus Gen 3 driving on open public roads with no hidden helper? As of now, no. Treat any viral clips as unverified until Tesla posts the full, continuous, multi-camera take and engineers walk through it frame by frame. But the path from walks to works to drives follows the same logic that shaped this project since day one. Reuse what scales *** vision, learning, OTA, ***, and wrap it in a body that can live in human spaces without remodeling the world. How a humanoid actually operates a car. If a human driver is eyes, brain, hands, feet, then a robot driver is cameras and tactile neural policy. Fine motor actuation. The head and torso mount a ring of high-resolution cameras that overlap for 360 degrees coverage. The network doesn't read pixels and react with if-else rules. It learns affordances. This edge is a lane. That motion pattern is a pedestrian. This flick of brake light and yaw is a hesitant merge. End-to-end networks compress the old pipeline into more brittle chains of detection, filtering, NG, and hand-coded planners. The same end-to-end thinking that made FSD V12 feel more human in cars is what lets a humanoid sit in a vibrating cabin, decode the world through glass glare and raindrops, and still form a plan. A good driver isn't just compliant. A good driver is anticipatory. The policy predicts nearby agents' trajectories, not just their positions. The pickup drifting at plus 0.3 meters per second laterally. The cyclists wobble as a low-confidence sinusoid. The late yellow decision of the sedan whose brake lights flicker but don't catch. That's where Tesla's fleet advantage matters. The robot doesn't need to rediscover what the car brain has already learned about merges, cut-ins, and stale greens. In a vehicle, the policy is based on steering angle, torque, and pedal percent. In a humanoid, those same intentions become wrist torque, finger joint force, ankle flexion, and knee position. You can think of the hands as compliant end effectors that mimic the micro-adjustments of an experienced driver. Slight wheel preload before the lane crown, feathered braking as weight shifts forward, thumb and forefinger bias for steady tracking over expansion joints. The seatbelt's pressure and the seat pan's IMU readings feed back into tiny counter motions, so the grip doesn't jitter when the chassis hits a pothole. Real driving is not only visual. You feel when the wheel goes light on slick paint. You sense the pedal's stiffness changes on a steep grade. With fingertip tactiles and wrist torque sensors, the robot gets those microsignals. That's how it centers the wheel without hunting, applies a brake plateau instead of a sawtooth, and can set a gentle clamp at 10 and 2 that survives a speed bump without overcorrecting. You'd be surprised how much driver performance comes from posture. Micro IMUs in the spine and shoulders dampen vibration. Dynamic elbow compliance soaks up cabin jolts, keeping the fingers steady in contact. Neck roll, pitch stabilizes the visual horizon so the network doesn't see a stuttered world during bumps. The result, steering that looks almost lazy to the eye, is a good sign. Even if the robot is acting as the driver, the vehicle's native ADAS can stay armed as a safety layer. You also want an e-stop within reach, a heartbeat channel to a teleassist console, and OTA logs that let engineers reconstruct every decision tree. Early deployments wouldn't be public highways. They'd be closed campuses, yards, depots, and service centers where policy training is faster, edge cases are bounded, and legal exposure is sane. Put it together, and a believable first driving sequence looks like this. The bot seats itself, runs a quick mirror, seat calibration, signals, rolls out, yields to a crossing pedestrian scrubbed in glare, merges onto an internal ring road, performs a patient pass around a slow cart, returns to lane center, and later lines up a charge stall as precisely as a CNC machine, zeroing an axis. No heroics, just clean intent. The milestone that matters. The internet will explode the day Tesla posts a continuous, independent, multi-angle, engineer-narrated video of a humanoid merging onto an actual highway. But here's the quiet truth. The economic milestone lands earlier, with less spectacle, in places without press passes. Think about service centers. All day, cars need to be moved out of customer lanes, into a bay, to the wash, to the charger, back to pickup. Most of that is low-speed operation, with lots of mirror checks, awareness of pedestrians, and tight bay parking. A human is excellent at this, but a robot with the same visual policy as the cars themselves, plus gentle manipulation, can do it all day without losing patience, attention, or accuracy. Now think factory yards. Vehicles flow from end-of-line to inspection, to software flash, to logistics staging. At shift change, there's a rush of cars that need charging, reparking, and key handling. The robot's hands are the adapter to all the human-designed knobs, stalks, and doors. The fleet intelligence is the reason it doesn't need rulers or taped arrows on the floor to know where to go. Next, delivery compounds and private campuses. These environments are perfect for early deployment because you control the space, you log everything, and you can tune the policy faster than a city can pass an ordinance. A humanoid doesn't replace automation. It bridges the last 20% that fixed robotics can't touch without remodeling the world. This is the heart of Tesla's more significant than vehicles thesis. If you take a brain, already improving at scale in millions of cars, and you put it into bodies that can work anywhere humans work without rebuilding the world for robots, you don't get a neat party trick. You get compounding utilization. The value doesn't come from a viral merge clip. It comes from 1,000 boring tasks done perfectly, every day, across thousands of sites. And yes, public roads will come slowly, sanely, domain by domain. But by the time a humanoid cruises down an actual interstate in an official demo, it'll be narrating a story that already started. Robots moving vehicles at midnight while most of us sleep. Why this is hard and still inevitable. Hands are the mountain. Even Musk says most of the pain and cost live in the hands and forearms. You need tendon-like transmissions, back-drivable joints, fingertip tactiles, and a controller that can flip from soft as mayonnaise to firm as a lug wrench in milliseconds. Without good hands, the steering feels choppy, stalks get missed, and centerline parking becomes bumper car theater. With good hands, everything else suddenly looks easy. Edge case chaos is relentless. A kid breaks from a parent's grip in a lot of ways. An SUV with tinted windows backs out fast. Sun glances off a puddle and saturates half the frame. Vision-only autonomy lives or dies by how well the network has seen similar chaos before and learned to generalize. That is the strongest argument for Tesla's approach. No one else trains on car-scale video volume at car-scale frequency. Mass production is a different sport. There is no established supply chain for humanoids. Tesla will have to vertically integrate actuators, gearboxes, harnesses, and skins to automotive quality standards in automotive volumes. The upside is they already live in that world. The downside is every module that isn't standardized is a fresh program. Security and ethics are not optional. A capable humanoid is powerful. Software needs hard boundaries. OTA needs cryptographic guardrails. Remote assist needs strict privilege. In early deployments, access control, audit logs, geofences, and roll limits will matter as much as hand torque. And yet, look at the trajectory. Gait got smoother, grasp got gentler, perception got more human-like, latency dropped, OTA marched on. The direction of travel isn't up for debate, only the timeline is. The future of Tesla isn't just about self-driving, it's about self-doing. A single AI learning to think, move, and act whether behind the wheel or on the factory floor. When the robot takes the driver's seat, it's not a stunt. It's the quiet start of a world that runs itself.